All right, so here's some help on how to do the next v function, okay? All right, so what we want to do is we want to write a function next v, okay, that will consume the current velocity, okay, and produce the velocity at the next tick, okay? Hint, this should work for any value of delta t, all right? So you want to think about kind of exactly like how we did next x, sort of the same idea. All right, so if you remember when we did next x, we did, oh, that's ugly. We did next x of current x, okay? And then originally we had current x plus delta x, right? Remember way back when we added, like, your buggy went 30 centimeters plus 30 plus 30, okay? Eventually we got this delta x, okay, to become velocity times delta t, right? Because if it was like, 8 or let's say 30 centimeters per second, if I only wait 1 second, then my delta x is 30, right? But if I wait 2 seconds, right, I've waited longer so the buggy would get further, then my delta x would be 60, okay? So that's how we got our delta x to turn into something that's time dependent, right? Because the longer I wait to draw the buggy the next time, it's gonna get further, okay? So this is sort of the same idea now, all right, is we want to find out how fast the buggy is going at the next tick. Okay, we don't really care where it is at this point. We don't know how to do that yet, okay? So we want to figure out what's the next velocity of the buggy, okay, based on its current velocity, all right? So if you look at this table, right, here, for example, if my velocity is 8 centimeters per second, at the next tick, it's 16. At the next tick, it's 24. So what I'm doing is I'm adding 8 centimeters per second every tick, okay? That's when the tick is 1 second long, right? So my next v function might look something like current v, okay, plus 8 in this case, okay? That is for a 1 second tick only, right? Because if it's 1 second tick, I know I'm going to be adding 8 centimeters per second to get to the next velocity, all right? Now, what if I don't wait 1 second, right? What if I wait 2 seconds, right? Is it going to still only get 8 centimeters per second faster if I wait 2 seconds? Okay, let's look. Okay. No, right? Because look, if I wait 2 seconds, I'm going to go from 8 centimeters per second. If I wait till 2, I have to get all the way to 24. I'm sort of skipping that middle one, okay? So in that case, I'm going to add 16 centimeters per second, okay? So I'd add 16 if it was a 2 second tick, okay? And then what if it was only a half second tick, right? So instead of adding a full 8, if I only wait half a second, I only add 4, all right? Because I'm not waiting as long, so the car didn't have as much time to get faster. So if I add 4, this is for a half second tick, all right? So just like before, we don't want to have to keep going through figuring out how much, like that's a hassle. We want to just teach Pirate to just figure it out for us, and then we can put any delta t in there. We can make the tick a tenth of a second or 5 seconds or 25 seconds or 0.0001 seconds, whatever. And Pirate will just figure it out, okay? So this that I'm adding is actually the delta v, okay? So again, at its core, this function is the current velocity plus some change in velocity, okay? How do I know how much velocity to add, right? Well, when it was 8 centimeters per second, in 1 second, I added 8, okay, right? But if it's 2 second tick, I need to add 16, okay? So if it's a 2 second tick, I need to add 16. So see that ratio that we talked about, that 8 centimeters per second, or that acceleration ratio is still the same, right? Because it's still only adding 8 centimeters per second every second, okay? Oh, wait, 8 centimeters per second. Oh, per second. Oh, my God. 8 centimeters per second, because that's how much I'm adding, right? That's the acceleration. I have the units wrong, okay? right? So then if I go 8 centimeters per second, right, that's my acceleration, but I only wait half a second, that's how I'm going to end up adding 4, okay? Right? So this is my acceleration ratio, right? Because no matter what kind of tick I use, 8 over 1, 16 over 2, 4 over half, that always is going to come out to 8. So every 1 second, I need to add 8 centimeters per second, okay? So if I multiply that by the delta t I want, that's going to tell me how much delta v to add, okay? So my acceleration is going to be the same, times the delta t, how long I wait, is going to tell me how much velocity to add, okay? All right, so really it's going to turn out like this. My velocity next is going to be my initial velocity, right? That's the v naught, plus delta v, which is the same as acceleration times delta t, okay? So you see how this looks just like the next x function, but it's not. It's now the next v function, but it's a similar idea, okay? I'm going to have my next v is going to be my current v, and then I'm going to add some delta v, and I can calculate that by taking my constant acceleration rate, in this case, 8 centimeters per second, times delta t, and that's how much I'm going to add, okay? All right, so if I finish out this function, current v plus, I can write this in pirate terms, acceleration, and then I got to use the pirate multiplier, delta t, okay? All right, so that's what we're trying to program, okay, and that's why, all right? You might get asked this on a quick quiz or the test, so make sure you can understand why we're doing this, all right? Okay, now for the design recipe, okay, what are we going to need to know? Well, we're going to need to know the acceleration, okay, and in our case here, it's 8, oops, I can't write it there because it's pirate, 8, and then units, centimeters per second, okay? And I also need to know what delta t I want. Okay, let's just do 1 second. I don't know, it doesn't matter. You can change it to whatever you want, okay? And I don't really need another identifier. I could, technically, if this was like a simulation, I would need to know the initial velocity, like how we did initial position before, okay? But there's no simulation yet. In this time, we're just gonna program it, so this is kind of irrelevant. We don't really care about this at this point, okay? All right, the inputs to the function, okay? I'm always gonna input and take in my current velocity, in centimeters per second, okay, and my output is going to be the next velocity, or the velocity at the next tick, also centimeters per second, okay? All right, we're going to call this function next v, okay, and since I'm inputting a number, my contract's going to read number, and I'm outputting a number, okay? The function consumes current velocity, okay, and produces, okay, the next velocity, or I like to say the velocity at the next tick, okay, because this object is now getting faster and faster and faster, okay? All right, so my examples, again, doesn't really matter what you use, let's do 2, whatever, okay, is now, if these are my right values, okay, 8 and 1, okay, if my current velocity is 2, 1 second later, my velocity is going to be 10, right? Because I'm going to be 10 because 2 plus my acceleration is 8 times my delta t is 1, okay? Maybe I should have picked a more exciting delta t, but that's fine, okay? Next v of, I don't know, let's say 20, whatever, okay, is, all right, so if I'm adding 8 centimeters per second in 1 second, I'm going to have 20 plus my acceleration is 8 times 1, okay? And then that would give me 28, okay? And how about next v of 10, okay, is going to be, I'm going to start at a velocity of 10, and I'm going to add 8 centimeters per second in 1 second, and my next v is going to be 18, okay? That's fine. Whatever, you can pick anything you want, okay? All right, function next v. My input is going to be current v, and I suggest still using the word current v instead of just v, because it's going to make the next thing easier, I think, okay? Next v of current v, okay, so I'm going to do my current v plus acceleration times delta t, like this, okay? Don't forget the little asterisk, okay? Remember, this part is your delta v. This is what you're adding. This is how much velocity you're adding okay, with a constant rate of acceleration times however long you wait until you look again. The longer you wait, the more velocity you need to add because, I mean, duh, it's going faster every second. So the longer you wait, it's getting faster and faster. Okay. All right. Then you're going to go to Pirate. Just open the regular Pirate code editor. There's no starter code for this. Okay. And then you're just going to program in, right? Hashtag identifiers. This part you don't have to put in, I guess. And then, hashtag contract, hashtag purpose statement, hashtag examples block, okay? And then hashtag function definition, and then write the whole thing, okay? Once you type it in, okay, there's no starter code. You just need to run it, make sure your examples pass, okay? And then simply on the right side, just type in next V of, 15, okay? And then it will return the answer, okay? Next V, of whatever, and then you return the answer, okay? As long as it matches what your code is, okay? It looks like on this one I also did +8. I wouldn't do any negative numbers even though I put one there.